Okay, this is a quick introduction to investments and loans, which is another topic that we're doing. And in this one, we are looking at investing money and borrowing money and how that all works. So a very quick recap on what you would have done in previous years is looking at simple interest and compound interest. Simple interest is when you invest the money once, and interest is calculated once. So as long as you remember it's done once and it's not compounded, it's just a flat calculation. It was also known as flat rate of interest. You have four equations that are worth knowing. I equals PRT over 100, whereas P is the principal, which is the amount of money you borrow or invest. R is the rate, and T is the term, and that's in this one it's in years. Okay, and I is the interest that you earn. Okay, so it's I equals PRT over 100, and you can see the other rearrangements there. You should know how to do this, so we don't actually spend a great deal of time on it. The next thing that you'll need to know is compound interest. Compound interest is when you add money gets added into your account, and then interest gets put on the top of it, and then you have a new principal, and it gets added on again, and it gets bigger and bigger. So visually, that would look like this. This would be the principal that you put in. Then you would get some interest on the top of that. And then what happens is it gets recalculated again over the term of the investment. So what happens is it now gets bigger. Notice that your principal is bigger because it's taking into account the interest that you've just had. Then you earn some more interest, and notice that your interest gets a little bit bigger because of the fact that the interest is bigger because your principal is bigger, and then it grows again. So your principal becomes bigger again, and then interest is added on. So it keeps on going like that. If you drew a graph of that, it would look something like this. It'd have this parabolic curve where it gets higher and higher and higher. So the longer that you have your money in the account, the higher it grows. The two formulas that you've seen before, you may have seen before, is A equals P bracket 1 add I to the power of N, or FV equals PV bracket 1 add I to the power of N. Similar things. A is your amount of money that you have at the end, and that goes with FV as well. So that's the future value of your investment, or A as the amount. P is in your principal, or as in present value, which is the amount of money you start with. So they're the only two things that are different. And I is interest rate per period, and N is the number of periods. So let's have a look at how to do this, because these are all done on the graphic calculator, so you really don't need to know how to use those formulas too much. So let's have a look. You invest $10,000 in an account paying 8% per annum, compounding quarterly. How much will you have after 10 years? So this is a question that you read through and you go, well, okay, I've got a chunk of money there, which is $10,000, or I've got an interest rate, and it says the word compounding, and it tells me a time, and we're looking for money after a number of years. With all these questions, because you're using the graphic calculator, you've got to get used to writing it out and setting it out properly, because in a test, all we get to see is what you put on your screen, and then you give us an answer. So we need to know that if you just put an answer down and you get it wrong, you'll get no marks at all. So let's have a look. On your screen of your calculator, you have to go to TVM. So you're moving down across, and it's down there. If you go execute, and you've got all these other things to go to. You've got simple interest, compound interest, cash flow, amortization, conversion, and a few other bits and pieces. We want to have compound interest, so you go F2. Notice that the window you have there has N, I, PV, payment, FV, payments per year, and then if you scroll down a bit further, it comes down to compounding periods per year. So they're the things that we need. So what you need to do on your bit of paper is to write down N, I, PV, payment, future value, payments per year, and then compounding periods per year. So those things you need to write down, and then you fill in what you've got, enter it into the calculator and solve it. But it's really important that you set it out with the N, I, PV, etc. down, otherwise it gets a bit confusing. So let's have a look. Put in what we know. You invest $10,000, so that's our principal. So we put in $10,000. And that's got to be negative, and I'll explain why. Your I is 8, your N is 10. It's compounding quarterly, so you've got to go 4 here and 4 here, and then we have to times this by 4 to get 40. Okay, because it's being done 4 times a year over a 10-year period, so it gets compounded 40 times. The future value we don't know, and we're not putting any payments in. Okay, so that's how you set it up. So on the calculator, when you go and set it up in the calculator, you put in the same thing. You can just go 10 and then times 4. Put in the I as 8. Don't have to do anything else, just put it in as 8. PV, make sure you put it as a negative, because what this is thinking it is kind of like a loan. So it's got to be paying it back. So it's got to be negative. If you don't put PV as negative, payment will become negative. As long as one of the two of them is negative, it'll work out. Payment we leave 0. Future value we don't know. Payments per year is 4. Go execute and then just scroll down, and automatically it will change your compounding periods to 4. But just check that, because you might have different ones. And then along here, we want to work out what our value is, and we're looking for FV, which is the future value of this, and so you hit F5, and you end up with an answer of $22,080.40. So 22,080.40 is the what's that accounting amounting to. So that means if you invest the money over 10 years, you'll end up with 22,000. So you'll double your money over a 10-year period. Okay, so that is a compound interest question. If you're missing any of these other things, like if you're missing, say, N or PV, and you're given all the other information, you'll just have one blank in this area here, and that's what you solve for. You probably won't get any of that in compound interest, but you will get it in annuities, which is the next thing that we look at. So let's have a look at what an annuity is, so you've got that sorted out. There are two types of annuities that we look at. One's called a future value annuity, and one's called a present value annuity. The only difference is where the lump sum of money exists. So future value annuity means the big chunk of money that you get to use exists in the future. So this is something like where you're putting money into the bank to save up for something, or you might be looking at your superannuation, where you're putting money away to have super when you retire. But the lump sum of money that you get to play with or use is in the future. So as long as you remember that, that's where a future value annuity comes in. Now, annuity differs from a compound interest question in a couple of ways. Let's have a look. So let's pretend that this is what is in your account, and you add a payment, which is a payment in here, and then on top of that you get credited interest. Okay, so then the next time around when this happens, you've got all of this in the bank. You still put your regular payment in. Okay, so these things have regular series of payments going into them, and then your interest again. So as you can see, what happens is the sum of money that you have sitting in the bank, the lump sum of money there, gets bigger a lot quicker. So once again, you put in another payment. Now your payments stay the same, even though my drawing isn't that flash, but your interest will get bigger each time, because the amount of money that you have, or the principal that you have sitting in the account, is there as well. So what happens is, it's similar to compound interest. You have from a long way away, you'd have a graph going like that, but if you zoomed in and had a really quick zoom in about what was going on there, you'd have something that goes like this. It goes up, oh, bit of payment, then whoa, then up, and so you get these big staggered things going like this, and your money grows very quickly over a long period of time. That's an annuity. It has a regular series of payments or deposits. Okay, that's the difference between a compound interest account and a future value annuity, or an annuity. There's a regular series of payments. So you've got to look for that in the question. So let's have a look at an example of a simple, just a straightforward future value annuity, and see how you go. You invest $500 per quarter in an account paying 8% compounding quarterly. How much will you have after 10 years? Now notice that you're putting in $500 per quarter. So that is a regular series of payments going into this account, a regular series of deposits. It's 8% compounding quarterly, and it's over a 10-year period. Okay, so you look for that word compounding, so it's got to be some sort of compound interest question, and then you look for whether it's a series of payments or deposits. Now we've got a series of payments going in here, so we know that it's got to be an annuity. Once again, we fill in what we know on the IPV type of thing that we had before. So we've got 10 years as our time. Our payment is 500, and that's got to be negative. Our present value is 0. Future value is what we're trying to find. Our payments per year are 4, and it's compounding 4 times a year because it's compounding quarterly and your payments are quarterly, and your I is 8%. And then you enter that into your calculator. So let's have a look and see what that looks like on the calculator. Just go back to where you were before, and then you just type in over the top. So we've got n equals 10 times by 4. Oops, that should be times by 4 here because it's done quarterly. Sorry. So we've got 40 already on the calculator. I is 8. PV is at the moment is at 10,000, but we just want that to be 0, so you can just delete that. We'll just put in 0. And then payment is going to be minus 500. It's got to be a negative number because it's like it's pretending, the calculator is pretending it's a loan. So you're taking money off the principal. Don't worry about that. Just put a negative there and you'll be groovy. Your future value is 0. We don't know what that is yet. And our compounding periods per year and payments per year are 4. So we're trying to find the FV. So you come across here until you find the FV button. So FV is F5. And you hit that, and that'll tell us what our future value is. So if you have a look at there, that's 30,200 or 30,201. So that gives you $30,201 is what your future value is going to be. Okay, so it builds up quickly and grows quickly just because of the fact that you are adding money regularly. This is how superannuation works, because you're putting money in regularly over your period that you work, and so then you've got a lump sum at the end that you can use. So that's how that whole thing works, and it's quite a good way of doing stuff. But you must look for the regular series of payments or deposits, and that it's compounding, and then you substitute it in. Over the next few screencasts that you'll look at, you'll just see the fact that you might miss one of these things in here, and then all you do is leave a gap and ask it to solve for that, and it'll work it out for you. So the calculator will, whichever one you're trying to find, it will do it for you. It'll just change it around. So the other screencasts show you how to do that in detail, and they're also linked to the PowerPoints that you've got as well.